Hello everybody! In this Python tutorial we're going to go over the basics of classes and object-oriented programming. Before we get started, let's go over a few notes and a few definitions. OOP, or Object-Oriented Programming, is a programming model based on the concept of objects where collections of objects or categories of things are used with classes. Classes typically consist of methods and data with characteristics in common. The classes are then used throughout the program in a variety of ways, including the ability to create new objects, change objects, allow objects to interact and perform tasks, modify data, and other functionality. Long story short, classes can help you organize and reuse code efficiently. A quick note on methods. Methods are basically functions inside a class or functions that belong to objects. Now let's talk just a little bit about the difference between class and instance variables. To contrast class and instance variables, a class variable usually does not change based on instances and belongs to the class, whereas an instance variable is different for each instance of the class. For example, if you have a dog class, a class variable for the common ancestor of the dog is wolf, and that will not change based on the different instances or dogs, whereas the instance variables or dog characteristics will be unique to each instance or dog. And we'll show you some examples of that in our code. A quick note on self, because you're going to see self a lot in the code as we go through it. Basically, self represents the instance or object itself. Think of self as the instance or object you will create when you use your class. Self is a convention, and you don't have to use the word self. However, self is what is commonly used. And again, we'll go over the specifics of how to use self in our code. We will also be going over inheritance, and a simple example of inheritance is when a subclass inherits all the functionality from a parent or superclass. And one last note on indentation. In classes, indentation is important for scope, just like in all Python code. So just as curly brackets in other languages denote scope, in Python, indentation is used. So when you have errors in your code, one of the first things you want to do is check your code for proper indentation and scope. Okay, so let's go ahead and get started with our code. The syntax used to declare a class is just simply the word class in lowercase, and then the name of the class, and the class name is usually in title case or something similar, and then you put a colon. So here we have our first example of a class variable for our dog class. We have the variable of common ancestor set to wolf. Next, let's go over the init method, and this is sometimes referred to as a constructor. And you use the init method to help create initialized instances or objects from your class. To declare an init method, you use the def keyword, and then you use 2 underscores, and then you type out init, and then another 2 underscores. And then inside your parentheses, you declare the variable names that you want to use in your class. Now, one thing that we should point out, and this is the first example of self, is in this case, the self inside of the parentheses after the init, and I believe this should always be the first parameter, refers to the instance that you will declare. So in this case, it specifically refers to dog1, which is this instance that we have declared here. Okay? So as we mentioned before, in our notes, when we were talking about self, self represents the instance or object itself. So this init method, in a way, you can think of it as asking a question, and the very first question it always asks is, what instances will I be working with? And we can just put self in there to refer to any instances that we create. And as we mentioned, in this specific example, that instance would be dog1. Next, within our init method, we want to type out self and then the variable names and then assign those to the same variable name. Now again, we're using self, and when used with these variables, self will refer to the specifics of the instance and assign the values accordingly. Now a quick note, the self.variable names do not have to be the same as these variable names here. So you could change this to a self.type equals dog type, and that would work. But it's a common convention to go ahead and leave them the same. Okay, so that's how you create an init method with the types of variables that you want. Next, let's move on and go over how to create an instance of a dog class and fill it in with the data. A quick note regarding an instance of a class is also known as an object. So you can use those two terms interchangeably. So to create an instance, you just create a variable name, and for this instance, the variable name is dog1. Then we have assigned that using just one equals sign to the dog class, and as soon as we start our parentheses, it's going to ask for those variables that we put into our init method here. So it's going to ask for the dog type, the dog name, the dog age, and the dog weight. So here we have put in the dog type, Boxer, the dog name, Sparky, the dog age is 5, and the dog weight is 54. Now, as soon as you have created your instance and filled it in with the proper information based on whatever you've put into your init, you can now access this instance, dog1, in many different ways. So one way to do that is to use the print to display, and we've used our instance dog1. We have used a dot to access the elements of that instance, and in this case, we have accessed the dog name. So if we select this and run it, we should get Sparky. And over here in our console, you can see we get Sparky. Now we can access the other elements of that instance as well. So let's type out dog1 and let's access the dog type. And let's type out dog1 again and let's access the dog age. Type out dog1 again and let's access the dog weight. Now, if we select this and run it, we should get all of the dog's characteristics, and we do. We get Sparky, who is a boxer, 5 years old, and 54 pounds. Now, another note on creating instances. So here we have created another dog instance called dog2, and we're not going to use this one because it uses all of the same characteristics. But if you wanted to use the specific names inside the parentheses, when you declare your characteristics, you can do that as well. So in this case, we have used the specific characteristic names of dog type, dog name, dog age, and dog weight. And that would just help provide a little bit more visual information about what goes into your dog instance. Next, let's use another print statement to display the information from our dog1 instance. However, let's put it in a little bit more meaningful visual form. So in this case, we have used a type of string interpolation, and we've used curly brackets as placeholders for all of the dog's characteristics. So we have 5 sets of curly brackets, and each of those curly brackets serves as a placeholder. So in each of these sets of curly brackets, we're going to put in our dog characteristics. So for the first set, we're going to put in the dog type, then the dog name, the dog age, the dog weight. And what's a little bit different in this example is that we have accessed the class variable for the common ancestor, which is the wolf here. So let's go ahead and select our print statement and run it. And you can see for our dog1 instance, we have an output that is a little bit more descriptive than our previous print statement. So we can see that the type is Boxer, whose name is Sparky, the age is 5, the weight is 54, and here we access the class variable, which was wolf. Notice there is a difference in how you access that variable. So in this case, we use the class name dog here, which we declared up here, and then we used a dot to access the common ancestor variable here. And you can see that returned wolf in our display output. Okay? In our next example, let's use some of the instance data to help us make a decision. So what we're going to do is use an if statement, and we want to check the dog's weight. So we're going to use our instance of dog1. We're going to access the dog weight using the dot, and if that weight is less than 55 pounds, we want to display a message that says the dog needs to gain weight. So if we select this and run it, we get the message, Sparky needs to gain weight. Okay, now let's move on to some examples using inheritance. So here, we have created a superclass or a parent class. The class name is account. We've used our init method or constructor here, and this is just asking for some very basic information, which is the customer name. We use the self.customerName, assign it to the customer name, and here we have created a variable for the email to create an email based on the customer name. Okay, so this is the superclass or the parent class that we're going to use in our subclass. Next, we created our subclass. And to create a subclass, you declare your class, and then inside parentheses after the subclass name, so our subclass name is checking, we've put the parent class name of account. So this checking subclass now has all of the functionality of its parent class, which is account. The first thing we did is we created a class variable, and this class variable is a starting point to help count the customers of this financial institution or bank. And a quick note on class variables versus the instance variables. So here we have a variable which will store the balance for each customer's account. One thing to note is that you could put that variable here, but that probably would not be a good thing to do because you want your balance variable to be unique to each customer and to only apply to specific customers or specific instances. So if you were to put your balance variable here, you might actually even get the right information half the time, but that's not something that you would probably want to do. So again, you want your class variables to be variables that can apply in an overall sense to all instances of the class and won't change, or won't be specific to, in this case, specific customers. Okay, so moving on to our init method. Here we have declared our init method. We use the def keyword double underscore init double underscore. Of course, we've put in self to refer to the instance that we will create, and then we declared the variables that we want for this init method. Now notice that the customer name is the same as in our init variable in our parent class, okay? And then the other two variables are different and specific to this checking account class. Now since we put in the customer name variable here, you want to do some type of a super init to allow for proper inheritance of that variable. And there's several ways you can do that. One way is just to use the parent class name, a dot, and then the init syntax. Now another way to do that would be simply to use a super init, and the syntax for that looks like this. And then inside this last paren here, you would put the customer name variable. And I believe when you use this syntax inside the parens here, you don't need to put the self. But we're going to go ahead and use this syntax for now. So that takes care of the customer name variable inheritance. Then for our other two variables that we've added, the account type and account number, we just simply create those the same way we have before. Self.accountType equals account type, self.accountNumber equals account number. And as we mentioned before, we created a balance variable, and we've set that equal to 0, which will help us keep track of each customer's balance after they have deposited and withdrawn money. Now, one last thing we did here under our init is we access the class variable, number of customers, that we declared up here. And to do that, we just use the class name, a dot, type out number of customers, and then we use this special syntax, which is a plus and an equal sign, 1. And this will create a running total of customers each time this init method is used. So every time an instance of the class is created and we give a new customer an account, this syntax here will add 1 to that, and thus helping us keep track of the number of customers that we have, or that the bank has. Okay, so the next thing we did is we created a deposit method. To do that, we used the def keyword. We gave the method the name of deposit. The first parameter, or the first argument that the method will take, is self, which refers to the instance that we use the deposit with or on, and then the real argument that it takes is the amount of the deposit. Next, we use self.balance. We use our special syntax plus equals to help us create a running total, and then the argument that's passed into the method here will be applied to the balance. So if we deposit $200 3 times, this syntax here should add those 3 deposits of $200 up to $600. Okay? The next method we created is the withdraw method, which is basically the same as the deposit method, but of course you'll notice one difference here. Instead of a plus equals to keep a running total and to add to the balance, we use a minus equals, which will keep a running total to subtract from the balance. Okay, so moving on. Here we have the first customer, or the first instance of the checking class. For the customer name, we put in Bob Smith, and you can see that was here. For the account type, we put in checking, and for the account number, we put in 123. So now that we have the instance created, which is the same as our first customer, we can use that instance, Bob, and we can apply our deposit and withdraw methods. So in this case, we used our method, we used the dot to access deposit, and we deposited $500. Then we used the instance again, we applied the withdraw method, and we subtracted $100. And then finally, we use a print statement to display Bob's current balance. So let's go ahead and select this and run it. And if we have set this up correctly, then Bob's balance should be $400. And you can see over here in the console, says Bob's balance is $400. Next, we created another instance of the checking class. We gave this instance the name of Jenny. So this is our second customer. And again, we just put in the customer name, the account type, and the account number. We used the instance Jenny, applied the deposit method and the withdrawal method, and then we used a print statement to display Jenny's balance. So if we select this and run it, she deposited $1,000 and then withdrew $200. So we should get Jenny's balance is $800. Run it and you can see Jenny's balance is $800. And finally, let's test our code that we created here to help us keep track of the number of customers. And that was based on each time we used the init method. So let's go ahead and select our print to display. And if we've done this correctly, we should get back 2. And you can see here in the console, number of customers is 2. Now I do plan on doing a few more tutorials in the future for more advanced class topics, including more on inheritance, polymorphism, property decorators, similar to getters, setters, and deleters, class methods, and static methods. But that's all we have for this tutorial on the basics of Python classes and object-oriented programming. Thank you for joining us, and we'll see you next time.